In this section, we're going to not only learn what the graphs of trig functions look like, but then we're also going to do all kinds of transformations on those graphs. So you'll apply all the things you learned in Precalc 1 about transforming logarithmic functions and parabolas. Now you'll apply them to sines and cosines. One of the things you'll want to do is fill out that exact value worksheet that's on Canvas if you haven't already. It's a relatively easy, it looks like it's a million things to fill out, but it's not really that bad. This is what that worksheet looks like. And so you start filling it in, like the sine of 0 is 0, so the exact value is 0, and the approximation is 0. For pi over 6, well, the sine of pi over 6 is a half, then you can fill them in from there, right? Square root of 2 over 2, square root of 3 over 2, and then 1. And then as you grab your calculator, obviously that's 0.5. The square root of 2 over 2 is 0.707. The square root of 3 over 2 is 0.866, and then that's 1. So as you go through, you can fill them out. They'll be positive, and then they'll be negative, and they'll all come back to 0. For tangent, you're going to find a couple of them that are not defined, like the tan of pi over 2 doesn't exist. So we could write that. We could say it's undefined, either one. Sine and cosine will have values for everything. Tangent will not have values for pi over 2, and then also 3 pi over 2. All right, so if you haven't filled that in yet, fill that in, give it a pause, and then come back. All right, so this is what my worksheet looks like when I filled everything in. I don't know why I did half of it in pencil, or a third of it in pencil and the other 2/3 in pen, but here we are. So I did sine, I did cosine, and then I did tangent. What I'm going to do with these is I'm going to start making graphs of these functions, and it's easier sometimes to use the decimal equivalent than to use the radical version of it. All right, so for the sine of x, the independent variable is theta. The dependent variable is whatever you got for sine and cosine. So at 0 radians, the value of sine is 0, so we put a mark at 0, 0. If this is pi over 2 over here, and it's divided up into 3 pieces, then a third of pi over 2 is pi over 6. So this is 1 pi over 6. This is 2 pi over 6s, which is also known as pi over 3. That's pi over 2. What's halfway between pi over 6 and pi over 3 is actually pi over 4, right? Because 45 degrees is halfway between 30 and 60. So at pi over 6, the y value is a half, and then it's 0.7, and then it's close to 0.9, and then by the time you get to pi over 2, the value is 1. And then it starts falling, right? Falling by that same amount. There's your values in here. By the time you get to pi, you're at 0. So it looks like the first part is a big speed bump. Goes up, turns around, comes down to pi. But then you notice what happens on the other side. Then it becomes negative. So it does it in that same way, right? Here's your markings in between. So if that's 9 pi over 6, we can think of this as 7 pi over 6, 4 pi over 3, and 3 pi over 2. So here, I'll put these up top because I'm going to have to go below the axis. Pro tip, don't write the scale where you want to actually graph. There we go. All right. So at 7 pi over 6, we're down to negative 1/2. And then by the time we get to 3 pi over 2, we're down to negative 1. So yeah, I might have skipped a couple in between. It's going to come down like this, and then by the time we get to 2 pi, it's going to go back to 0. So the sine, if you ever heard the term sine wave, this is part of a sine wave. And in fact, this is one period of the sine wave. Because you realize the sine wave continues, right? It goes past 2 pi and just goes on that way forever. And I could even graph it in this direction too, right? I could graph another piece from here that goes down at negative pi over 2, then back up at pi. But the actual period goes from 0 to 2 pi. So here, I'm going to fill some things in here. The period of the sine function is 2 pi. What's the domain? Well, I graphed only a little portion of it, but if you let this go on forever, it would go from negative infinity to infinity, right? I'll use open brackets for both of those. The range, well, you notice the lowest value you're going to get is negative 1. The highest value you're going to get is positive 1. Right? So the range we'll use the close brackets for, negative 1 to positive 1. The x-intercepts, well, there's a lot of them. There's pi, and then there's 2 pi, and then there's 3 pi, and there's 0, and there's negative pi. So maybe I can sort of shorten that by saying that the intercepts are pi n, where n is an integer. All right, so it would be negative pi, it would be 0 pi, right? 0 is an integer. 1 pi, 2 pi, 3 pi, and so forth. All right, the y-intercepts. There's only one y-intercept. It happens as 0, 0. We said the period was 2 pi because that's how long it takes before a cycle of the graph is complete. In other words, before it goes all the way up, all the way down, comes back to where it started. Amplitude, maybe that's a new word. Amplitude is how high the graph is from the center to the top. So if you look at my graph, it does go from -1 to 1, but this here is really the center of the graph. Sometimes we call it the midline. And so from here to the maximum is 1. So the amplitude is 1. And last question is even function or odd function? Well, if it's a reflection across the y-axis, it's even. If it has 180-degree rotation symmetry about the origin, it's odd. So if you imagine taking the sine graph and flipping it around 180 degrees around the origin, so there's your center of the rotation, spin this thing around 180 degrees, and you get exactly the same function. So it's odd. If you're doing this on a piece of paper, you can actually pick up the piece of paper, turn it around, and see that you get exactly the same function. And so just like you did even and odd functions in pre-calc, here comes even and odd functions again, except they look a little bit different. All right, so there's a graph of y equals sine x. Now, let's take a look at y equals cosine x. Right, looks very similar. My question's over here, except obviously a different function. So let's go back to that table of values. For cosine, the cosine of 0 is 1. So when the number of radians is 0, the cosine value is 1. And then here's your pi over 6 and your pi over 3. So at pi over 6, this thing is still pretty high, right? It's at almost 0.9. And then by the time it gets to pi over 3, it's down to 0.7. Then it's down to 0.5. And then by the time it gets to pi over 2, it's at 0. So this thing has a little arch like this, but then where does it go after pi over 2? It goes in negative territory. So negative 1/2, and then eventually by the time it gets to pi, it's at -1. All right, you can plot some more points here. I kind of know where we're going with this. So by the time it gets to 3 pi over 2, it's going to be back up to 0. And then by 2 pi, it's going to be back up to 1. So here is one cycle of the cosine graph. Notice that this one looks a little different than sine, right? There was sine, there's cosine. But here, if I draw a little bit more of the cosine graph, you might tell me that it looks like the sine graph pushed pi over 2 to the left, and that's exactly what it is, right? The cosine and the sine graph are the same graph, it's just that one of them is shifted pi over 2 to the left, or 3 pi over 2 to the right, right? This goes on forever, so you're not restricted to just those values. All right. Let's look at some things about domain and range. The domain is going to be the same as sine, right? -infinity to infinity. And the range is going to be the same too. You notice that the lowest possible value is -1, highest possible value is 1. So the range goes from -1 to 1. Now, where does this thing cross the axis? It crosses at negative pi over 2, pi over 2, 3 pi over 2. In other words, a pi over 2 plus pi. So how do I write that? Pi over 2 plus pi n. So it's still going to cross the axis every pi. Remember, sine did that, right? At 0 pi and 1 pi and 2 pi and 3 pi. Well, same thing here, except this will be pi over 2, 3 pi over 2, 5 pi over 2, and so forth. What's the y-intercept? Y-intercept is 0, 1. You notice the period of cosine is the same as sine. It goes from over here to over here. It takes 2 pi before that whole cycle gets completed. Amplitude is the same as sine, right? It's 1. But look at this. If I take the graph and I try to reflect it across the y-axis, it's not rotation symmetric anymore. It's reflection symmetric. I can reflect it across the y-axis, and I get exactly the same graph. So if I can do that, I got myself an even function. I think of those parabolas as you could flip over the y-axis, and you got exactly the same thing. Same thing happens here for cosine. That's also a reason that we go through why something is an even and odd function, because, yeah, you could say y equals x squared is even because it's got a second degree, but then cosine doesn't have any exponent and it's even. So it's important to understand how I figure out even and odd. It's because if I put in an x or I put in a negative x, I still get out the same y value. All right, how about tangent? Ooh, tangent's going to be very different. Why? Well, first of all, remember we said that tangent had certain values that were undefined. So if it has values that are undefined, then what's going to happen is we're going to create a vertical asymptote there. So at pi over 2, there's nothing, right? The graph is undefined. At 3 pi over 2, it's undefined. It turns out at negative pi over 2, it's also undefined. So my ability to draw on this tablet notwithstanding, you're going to end up with a bunch of vertical asymptotes here. So let's plot some points for tangent. The tan of 0 is 0. Okay. The tan at pi over 6 is 0.577, so that's close to 0.6. The tan of pi over 4 is 1. Then we go up to 1.7. Ooh, that's getting up here. And then it goes undefined. So you end up with something here that looks like this. What happens at 2 pi over 3, which would be this next spot over here? It says the y value is almost negative 2. Then it's negative 1. Then it's negative 0.6. Then it's 0. And then it's positive 0.6. And it's 1. And it's 1.7. So I end up with another branch that looks like this. And actually, if I complete the other half of that branch, like your chart didn't have any negatives on it, but I'll bet you this follows the same pattern on the other side. That if I go down, I get this, and then that, and then that, and I can finish the curve like so. So tangent is going to look a little bit different when I start looking at domain and range and intercepts and things like that. The domain is going to be everything except multiples of pi over 2 each pi. So how do I write that? X cannot be pi over 2 plus pi n, where n is an integer. So pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, etc. Different again from sine and cosine, look at the range. Right? There's no restriction on the range. It goes all the way up and all the way down. So the range goes from negative infinity to infinity. Right, where does this graph cross the x-axis? It looks like it crosses it here at 0 and pi. And I'll bet you if we did it again, we get one here at 2 pi. So the x-intercepts are multiples of pi. Right? And again, in both cases, we're talking about n being an integer. Y-intercepts. This thing only crosses the y-axis once at 0, 0. Now look at the period of this function. How long does it take before it repeats? Well, it goes from negative pi over 2 to pi over 2, pi over 2 to 3 pi over 2. So instead of repeating every 2 pi, it repeats every pi. Tangent graph really doesn't have an amplitude because it doesn't go up and down, and up and down, and up and down. So we'll just kind of leave that guy blank. Even or odd function. Well, if you take that center piece and you revolve it around, you rotate it around the origin, it will be an odd function. You'll have the same thing just looking at this middle piece over here. Obviously, it doesn't work for the other branches. But if you do this one here, rotate it 180 degrees, you get the same function back. This one has a question that the other two graphs didn't have, which is, what are their asymptotes? And sure enough, there are vertical asymptotes. And the vertical asymptotes are the same as the issues with the domain, except we're going to write an equation, so we'll put an equal sign there. That x equals pi over 2 plus n pi. So I could write things like pi over 2, negative pi over 2, x equals 3 pi over 2, x equals 5 pi over 2. Those are all the vertical lines that create those asymptotes. And so the tangent function looks very different from sine and cosine, right? There's sine, there's cosine. We said cosine is just sine shifted over pi over 2, but tangent is not. Take sine and divide it by cosine, it produces a graph that's very different from the other ones. All right, so now that we know what the basics look like, and we will graph the three reciprocal trig functions eventually, the next thing I want you to do is grab that second worksheet, that Desmos activity, and graph the different functions and see what's happening to each one. So they come in 3 pieces. I put them up here on the PowerPoint if you want. Otherwise, you can print out that sheet this up on Canvas. Graph the sine and then the 3 transformations. Graph sine and then 2 other transformations. Graph sine and then 2 other transformations and see what happens. So here, I'll show you how we're going to graph these, and then you can fly with the rest of them. And I want you to make a little conclusion after each one. Show me what you've done. All right, so I just went to Desmos.com, click on the graphing calculator. Up in the corner here, I'm going to type in y equals the sine of x. You notice that the directions said to graph it on a window from negative 2 pi to 2 pi. So over here where the little wrench is, you click on the wrench. For the x-axis, I'll write negative 2, and then notice I'm going to start typing the word pi, and it changes it to a pi. Whoa. And that's positive 2 pi. The step means just what do you want it to go up by. So make it go up by pi over 2. That's what the x scale means. And then for the y's, go from negative 3 to 3, go up by 1s. And we're in radians. All right, so there's your y equals sine x. The next one said y equals 3 sine x. Oh, look at that. I think I have to shift my screen. You can see the whole graph. Okay. And then the next one wanted y equals negative 3 sine x. And then the last one wanted y equals 1/3 sine x. All right, one of the fancy things you can do with Desmos, you can see the corners of my buttons here. Clicking on these will turn the graphs on and off. So if you only want to see the original and the last one, then look what happens. They still cross at the same points, except the difference is the purple one is not as high as the red one is. On the other hand, look at that. They still cross at the same points. They still go in the same direction, except the blue one is much taller than the red one is. And this one, they cross at the same points, but they don't go in the same direction. The green one goes down and up, whereas the red one goes up and down. So think about what's changing here. They're still crossing at the same points, so they're not moving left and right at all. It's the amplitude that's changing. And what I want you to see is that that number in front of the sine x impacts the amplitude. All right, so you fill in the other two, and I'll start the next video, and you can start that when you're done with the activity.